right, so let's keep going. So it's not a function. So here is another example. We can actually draw a correspondence diagram that is a function, okay? You know, we could draw one like we did already, but there's other examples we can actually do. I think in the past I would have students actually draw one, you know, in a face-to-face class, but let me just dive right into the answer. Well, one of the answers you can give. I mean, we saw some examples already. Here's another example we can do. So here I'm sending 1 to 6. Here I'm sending 2 down to 8. 3, I'm sending that to 2. 4, I'm sending that to 4, as you can see. So again, this is another example of a function, okay? This is another example, 1 second please, of a function, as you can see, because each input is only going to one output. Someone had a question, or?
Yeah, so let's say this was a question on like a worksheet or something, and you had us draw arrows. We would just draw an arrow to one number to go into another number, just to show that one goes into one, or?
You just need from each number in X, you only need one arrow coming out of it to something in the second set.
So it doesn't matter which number goes to what as long as it's one arrow, basically?
Right, exactly. I mean, there's different examples you're going to get the way you draw the arrows. Like this one here is actually different. Well, it's different from this example, right? Because the arrows are sending, because the inputs are going to different outputs. You know, the function is defined differently. Here we have 2 going to 2, for instance, whereas here 2 is going to 8. So it's another example of a function.
Okay.
Okay. Good question. Okay, so this is another example of a function here. Okay. Here's another one that might look tricky. Notice here, all the inputs are going to the same output, as you can see. All the inputs, right, in this function are going to the same output. That is a function, actually, because from each number in the domain is assigned to only one element in here. So in terms of a correspondence diagram, each element of the first set, right? Each element of the first set only has one arrow coming out of it. Again, that's why it's a function. You know, it's not like, let me go back to this one. It's not like this one where you have 2 arrows coming out of something from X. That can't happen. You know, you have this input having 2 outputs. That doesn't make any sense. However, here, the inputs all have the same output. That can happen. That's fine. There's nothing wrong with that. Yeah?
So every X value needs an arrow, but not every Y value needs to have an arrow going to it, right?
Exactly. I'm glad someone asked that because I really wanted to point that out. Notice that not everything in Y has an input. In other words, not every Y is an output from the function, right? That can happen. That can happen. Okay, very good. That can happen. I mean, the range here would only be 2. In this case, just a set containing 2, but 4, 6, and 8 would not be in the range. Okay, but everything in the first set in the domain has to be input, but not everything in the second set has to be output. In this case, only 2 is output, and that's okay. Very good. Just double check something. Right. Very good. Okay. Okay, good. Very good question. Any other questions? Okay, so correspondence diagrams, I mean, you can define functions, you know, through that, right? Through a correspondence diagram. And actually something that's slightly related, well, I don't know if it's really related, but relations is another way we can define a function. I mean, the whole point is you want to somehow specify that rule from the first set x to the second set y. How you specify that rule, you know, you can have many different ways of specifying that rule. You could specify that rule using a correspondence diagram, but another way to specify that rule is through relations. Okay. This is another way we can specify a function for two sets x and y. I mean, what is a relation? It's just any set of ordered pairs. Any set of ordered pairs is a relation. This is a relation. You know, 1, 4, 1, 2, 3, 9. You can probably guess that from a relation we can get a graph, but that'll come up probably next time. But anyway, this is what a relation is. Here's another relation, as you can see. This is another relation. Okay, it's just any collection of ordered pairs. Now, building on this, relations alone can have domains and ranges. In other words, the domain of a relation, by definition, it's all the first components. That is, it's all the x coordinates. You know, the first numbers here in each ordered pair. That's what the domain is by definition. Whereas the range is all the y coordinates, all the second components. In other words, it's all the numbers after the comma, so to say. So for this one here, the domain would be just 1 and 3. I mean, you really don't want to list an element more than once. Whereas the range here would be 4, 2, and 9. Here, the domain, right, would be -2, 0, and 1, right? All the x coordinates, 2, 0, and 1. Whereas the range would be 1, 0, and 5. So that's what's happening here with domain and range. But also from a relation, you could actually make a correspondence diagram. You could actually make a correspondence diagram with a relation. Basically, the domain would be your first set. The range would be your second set. And for each ordered pair, you can make an arrow like so. For each ordered pair, you can make an arrow like this. That's what we get here. So we can make a correspondence diagram from a relation. And we can really go the other way around. Namely, from a correspondence diagram like this, you could form the ordered pair AB, where again, the domain would be the first set, the range would be the second set. So you can go back and forth, so to say. And so then you can get, and then hopefully you can see, well, maybe, oh, we're not there yet. Okay. But so we can go back and forth between relations and correspondence diagram. So for example, let's suppose we had this as our relation, right? The domain would be 1, 2, and 4. Right? That's what the domain is. The range is all the y coordinates. So in this case, we would have 3, 4, and 6. 3, 4, and 6. So in other words, from here, and so this is what we would get, the domain and range, the 3, 4, and 6. And we can make a correspondence diagram. For instance, 1, 3, we would have 1 going to 3. We have that arrow. From here to 4, we would have 2 going to 4. 4, 6, 4 going to 6. So that's what we would have in a relation, and we get this correspondence diagram. And hopefully you can imagine going the other way. Namely, if we had this correspondence diagram, we could get the domain and range, and we could make the relation. Here's another example. I said again, this is a relation, right? So here we would have these ordered pairs. And from here, hopefully you can see that the domain would be 1. 1 is listed already. We don't list it again. 5 and 6. 1, 5, 6. The range here, well, that's going to be 2, 3, 8. 3 is listed already. 8's listed already. So that's it. And not only that, we can draw the correspondence diagram. I mean, you can see it's kind of crazy, well, maybe not crazy, but it's different because 1 would go to 2, 1 would go to 3, and 1 would go to 8. So we have 3 arrows coming out of 1. 5 would go to 3, as you can see. 6 would also go to 8. So we have this correspondence diagram. Okay, are there any questions on this? Yeah.
Yeah, so I have like 2 questions. So one is you can have one of the X inputs go to multiple Y inputs if every X input has a line, right? So like here, this is a function, right?
Well, no, it's not a function actually.
Okay,
It's just a relation. We haven't gotten to functions yet, so.
Okay. So, but
Okay.
you can have, so you can, for a relation, you don't necessarily need to have the 1 correspond to the 2. You don't have to have the domain and the
No.
range. Okay. Okay.
I mean, a
Thank you.
relation, you can do whatever you want, essentially. So,
All right.
okay. Does that help or?
Yeah, it does.
All right, good question. Right, remember, these are relations. I never said this was a function, right? You know, we can make correspondence diagrams and domains and ranges for relations, but we will get to making functions from relations. I mean, we do have to be careful because if I just gave you this correspondence diagram, hopefully you'll be able to see this is not a function, right? And why is that? Well, 1 is assigned to many elements. You can't have that in a function, right? You know, you can't have that. I mean, it's really special. I guess, well, I don't want to say special, but it's really useful. That's better to have 1 output for each input. I mean, you can get a relation from a function from a calculator. You know, the square root button, right? You put a number in, you type the square root, and you get back a number, right? Well, what if you got back 2 numbers or even 3? What if you did the square root of 9? You got, let's say, 3, -3, and I don't know, 0. Right? Well, which number would you use on an exam or something, right? You know, that would be tricky. You know, that would be, you know, what do you do, right? So having 1 output only is very useful. Okay. And here's another example. Again, I like to do examples. The domain, again, is 1, 5, and 6. Wait, let me